All right, we'll start the second half now, guys. We've now got Darwin Keke, who's come across from West Yorkshire today to talk about security analytics with. Sorry?
Cheltenham's not in West Yorkshire.
Cheltenham? Oh, come from Cheltenham. So we've apologies, he's come from sunny Gloucestershire. Cheltenham with security analytics with Fabric and Power BI, Darwin Keke.
Good evening, everyone, and thank you for joining. Thank you for being here today. Before I start, I want to thank the organizers of this event, and I also want to thank the sponsors. I also want to thank the sponsors, Salon and Robert Walters Group, for putting this event today. So, like everyone had previously when they introduced me, my name is Dalek Chigozo, a cyber security analyst and an independent researcher. So I'll go straight into it. So today I'll be presenting security analytics with Fabric and Power BI. So there is this assumption that raw data is useful intelligence, and in cyber security as well, we come across raw data very often. I know we have data analysts among our list. We have technology enthusiasts. We also have people who are into IT and cybersecurity. So raw data is not necessarily useful intelligence, because for raw data to become useful intelligence, there needs to be data shaping, there needs to be analytical modeling, there needs to be behavioral interpretation, there needs to be semantic modeling, I guess. So today, I'm going to be explaining all these to you. So what we see here is using behavioral analytics with Power BI and Fabric. So usually raw data is usually messy, and I know everyone, we have an idea of what raw data is. So raw data is usually messy. That's if you're into coding, right? If you're into monitoring or analyzing logs, you should understand that sometimes it comes out like in patterns. Sometimes it comes out in patterns. Sometimes it comes out messy. You have to sit for hours trying to identify the data that you're looking for. And this data you're looking for is basically machine oriented. It's useful for machines, but it's not useful for humans. It's useful for machines because machines understand this data. But for humans do not necessarily understand this data. So the reason why I'll be presenting this is to explain what happens when machine learning generates data. And we'll be using telemetry. So we know telemetry is an event system generated data. So telemetry is basically like an event system generated data, and it comes in large data sets. So raw logs are messy, noisy, useless at first glance. Insights come from shaping, modeling, and asking the right questions. So what are the right questions you need to ask? Some of the questions you ask is, why don't you directly use the raw data in the dashboard? Which I'm going to explain that to. So why most Power BI projects fail before visuals? There is this impression that Power BI failed because of the dashboards, but that's not true. Power BI failed because the underlying event data was never structured for analysis in the first place. So the real world thing is that usually it comes out with too many rows, it comes out with no clear schema, no time dimension clarity, and raw outputs alone are not useful intelligence. So raw outputs alone are not useful intelligence. There are different layers, there are different analytical layers it has to go through, which I'll explain in the next slide. It has to go from the transformation, it has to go for the analytical modeling, before it finally gets to the behavioral interpretation and the dashboard. So here we can see, based on my own research, what we can see here is, we can see a lot. It might be blurry at first, but I can tell you what it is. So you can see the version here. We say version, account, time, region. All these are raw data, and all this relates to the output of the useful intelligence, right? So the question we're going to ask now is, why is machine learning system, like, what happens? To understand the raw data, we have to first ask ourselves, what is missing? What is missing in the system? And that's why we're here. So what is missing in the system is basically, in most machine learning systems are designed to answer one question. And the question is this malicious or not? That's basically every question most machine learning systems or cyber security wants to answer. Is it malicious or not? But the real operational environment, the answer to this question is not enough. Right? So a prediction without analytical context has very limited value. For example, a machine learning model may classify a model, a machine learning process may classify a machine learning model may classify the process as malicious with a 0.2 prediction score. But that's not enough, right? Because even if it predicts it as malicious, there are some certain questions that still needs to be answered. And some of the questions is how did the machine learning model how did the machine learning model interpret the data? So this gap is what exists in machine learning system, because in machine learning system the focus is usually on model training. The focus is usually on improving the accuracy. The focus is usually on reducing false positive. But far less attention is given to even more crucial aspect, which is how do this machine learning, how do you operationalize far less attention is given to how operational monitoring, behavioral analytics, drill visibility, and analytical context. Many of you will understand what the behavioral analytics is all about. So, as a result, many organizations end up with machine learning systems that generate outputs or predictions, but there is no scalable way to understand behavioral trends. There is no scalable way to understand false positive. There is no scalable way to understand confidence degradation. False positive happens when a machine learning or false positive happens when a process detects when a machine learning model detects a process as malicious that is not malicious. And this affects the confidence level of business analysts. Imagine sitting in your computer trying to go through logs and all you're getting is false positives. As well as behavioral analytics. So behavioral analytics is when a model can change. Sometimes when a model changes its pattern. So when a model changes its pattern, so it can change its pattern, and then the model is different from the pattern. So this is the challenge. This is the challenge is that this is where the gap is missing. Like this is where the gap is missing in machine learning. So the challenge is usually how do we structure, how do we model how do we analyze, and how do we communicate this data effectively. And this is where we have to build the missing analytical layer. So what is the missing analytical layer? It is how the raw machine output moves through a pipeline, how it moves from the telemetry to the transformation to semantic modeling to behavioral analytics, and finally into Power BI dashboards designed for investigation and insight. So, to understand why this analytical layer is complex or is difficult to build, we first need to look at what telemetry data is all about. Let's look at what telemetry data is all about. So before we analyze the machine output, we need to understand what raw telemetry is. So in traditional telemetry is usually structured, it's usually clean. For example, what your sales data is usually clean. It comes out like a clean sheet, right? But modern telemetry is the opposite. So modern telemetry behaves differently, right? It behaves differently. Like in machine learning systems, we are dealing with semi-structured event data, we are dealing with continuous event stream. That is, when continuous event stream is when there is a large amount of event stream coming in. So traditional data, right, cannot process a very large quantity amount, but what telemetry can process, a large quantity of data coming in. So telemetry actually, like I said, it refers to automatically generated machine or system event data collected for monitoring and analysis. And in my own research in cyber security, for example, what I understand is telemetry can be, from what you can see, telemetry is, okay, this is event log, right? If you go on your computer and you go to process monitor or you go to event viewer, you will definitely see something like this. What they say, this is all telemetry, this is all information, right? And if you have a large amount of computers, right, and you need to go through all this information all at once, then there will be a lot of information that you need to go through. And that's where dashboards come in place. Because dashboards can help you to automate this process. So it can help you to automate this process and make it more organized. However, for the telemetry, because it's a semi-structured event data, right? So this is where it's lacking, because for semi-structured event data, it won't come out as useful intelligence. It won't come out as analytical insights. It will come out as normal outputs. It can come out like JSON. It can come out like JSON. It can come out like XML. Right? The machines literally understand this information, but humans actually don't understand this information. Right? So example of for example, a single telemetry event may contain timestamps, process metadata, nested feature vectors, prediction output, and behavioral attributes. So to understand raw telemetry, we need to move to the next slide, which is end-to-end analytical pipeline. So this is the analytical pipeline that's going to shape the dashboard, right? So this is the machine learning output. This is the raw telemetry. From the raw telemetry, it moves down to the Fabric Lakehouse, and then transformation layer semantic model, Power BI, and finally behavioral insight. I'm going to go deeper into the explanation. So the Lakehouse acts as a central storage layer designed to scale and hold raw telemetry data from multiple sources. Already I mentioned what machine learning output is. So for machine learning output is events data, right? Event data. Machine learning output is event data. It can be registry, right? It can be registry. It can be timestamps. It can be DLL. It can be DLL. DLL is dynamic link library. So all these are outputs from computers. So the data acts as a central storage layer designed to scale and hold raw telemetry data from multiple sources. So when these outputs are gathered, it moves to the Fabric Lakehouse. So the Fabric Lakehouse is like a storage unit. This is a storage unit that processes the output. Yeah, it's a storage unit that processes the output. So the idea here is that insight does not emerge directly from raw predictions. Yeah, I know this is a bit technical to understand, but I believe I'll break it down in very layman language. So the idea here is that insight does not emerge directly from raw predictions. So instead, insights emerge progressively through multiple layers of transformation, modeling, and analytical refinement, which is these 6 layers. So, and these outputs may include prediction, level, confidence scores, anomaly indicators, behavioral feature vectors, and event stream data. So, like I said initially, in my research, telemetry was generated from behavioral analysis techniques such as API call monitoring, DLL activity, operational code analysis, process execution behavior, and dynamic malware analysis. So in this process, right, this is how the output is being transformed into behavioral insights. And behavioral insights is the last stage, right? So behavioral insights is the last stage. When it gets to the transformation layer, this is where a bit of progress happens, right? So the malware outputs, this is the machine learning output, this is where your raw data is. Fabric Lakehouse stores it. Fabric Lakehouse stores it. The transformation layer tries to amend it into an output that the machine can learn, right? Then the semantic model now try to change the language. Let me use the word language. So the semantic model try to, like, we are all here, we all speak the same language, right? So the semantic model is like, it tries to make it to seem like we all speak the same language. And then the Power BI analytics, when it moves down to the Power BI analytics, that's where the real solution happens. So it moves down to the Power BI analytics, and then that's when we now start to get the behavioral insight. So all this happens, and how we get to that state is flattening of nested JSON. So flattening of nested JSON is, for many of you that have seen the JSON, right? You know there's like a comma, then it goes down, it breaks down, then like, you know, Python language, right? You know Python language, it goes down, break down. So when you flatten it, you now make it to be in a straight line. You know, that's what flattening is. You flatten it so that you can be able to pass it out. So, and then it now cleans the invalid records. So it cleans the invalid records. So in raw outputs, you get invalid records. So it cleans the invalid record as well as normalize repeated entries. So when there are repeated entries, it normalizes it. For example, when you see like maybe Windows 11, it normalizes, okay, it breaks it. You know, normal dashboard has tables and rows. So it does that like putting the Windows 11 in the particular row, so that you don't have multiple Windows 11, you just have a single row that's normalization. So enriching behavioral context, so an engineering analytical attribute, as well as devices, users, timestamps, and malware families. So it does that to devices, for example, iPhone 17 Pro Max in a particular row. So this is what the stages, right? This is how it gets the analytical pipeline. This is how it works in the analytical pipeline till it gets to the behavioral insight. And then the enrichment as well. So enrichment means adding analytical meaning to raw telemetry. So it adds analytical meaning to raw telemetry. So finally, it gets to the Power BI and analytics. So once the semantic model is established, Power BI becomes like behavioral analytics layer. And then the final outcome, which is the behavioral insight. So it's not just dashboard, it's about operational visibility, right? It's about the operational visibility. And once we understand the complexity of this telemetry, usually the next question is, what kind of architecture can handle it effectively? What kind of architecture can handle it effectively? And that's where the Fabric comes in place. So Microsoft Fabric is an architecture that can handle it effectively, in the sense that it's a house that all the previously mentioned pipeline can be in, and then what you put in, it does all the work for you. So it's more like it's more telemetry analytics. It's more like how would I put it now? So instead of a separate disconnected system, right? For example, instead of a separate disconnected system for storage, transformation, modeling, and reporting, Fabric integrates them into a single analytical environment. So that's the exact point I was trying to make. So it integrates, like the Fabric integrates all these 6 layers into a single environment. So what telemetry data is really suitable for direct analytical use. It's common sense that we cannot, like, it's common sense that raw data cannot, if you are analyzing raw data, right, it's not necessarily useful, right? It's not necessarily useful and cannot be used directly for analytical use, even though sometimes you might find raw data useful, right? As an analyst, you can find, as a business analyst or as a BI specialist, you can find raw data useful at times, but most times it's not suitable for direct analytical use. And then nested JSON structure, like I mentioned, inconsistent schemas, missing values, must first be transformed into structured analytical data set. So for it to be useful, it has to be structured into analytical data sets. And this transformation process includes, like I mentioned, flattening. When you flatten the JSON, cleansing, when you cleanse it, normalization, like what I mentioned before, when you normalize it into data sets, okay, you normalize it into data sets, and feature enrichment and feature engineering to create meaningful behavioral attributes for analysis. Finally, analytical quality depends on the transformation quality. So what you get as the output, what you get at the end of the behavior at the end depends on the data shaping, depends on, so if you put in a very good analytical quality, right, you get a very, at the end you get a very good transformation quality. Okay. So the next challenge is usually the structure. That is so analytical modeling and semantics layer. So analytical modeling structures telemetry into optimized relational patterns for scalable behavior analysis. For example, is the facts table, which stores measurable telemetry events, as well as the dimension table provides analytical context such as diverse timestamps, malware families, and model version, as well as the semantic layer, which defines reusable measures, relationship, and analytical logic that improves scalability, compression, and query performance. At the end, good modeling enables scalable analytics. So, usually after the transformation, the next challenge becomes the analytical model, and that's where the real hard work happens. So once the semantic foundation exists, we can now begin measuring the behavior over time. So this is measuring the behavior over time. So usually that enables telemetry to be analyzed as evolving behavior analytics rather than isolated events. So at this stage, the Power BI moves beyond reporting into behavioral analytics, and when this happens, when it moves into behavioral analytics, that's where progress happens. So once behavioral measures exist, the final challenge usually becomes communicating them effectively through dashboards. So when this happens, like if I go back to the previous slide, you see that okay, let me go back here. So usually when this happens, this is where it happens. So when this happens, then it moves to the behavioral insight. So the shaping moves to the behavioral insight. So these dashboards are designed differently from traditional executive reporting. So the goal is simply visualization. Visualization, and analytical dashboards review anomalies, surface deviations, and surface deviations, and so usually when you do a proper investigation into dashboards, you find out that what the outputs that you get, all it's as a result of the data modeling, the data shaping, the data modeling. It's as a result of that. So dashboard usually expose behavior, not just display metrics. So it also exposes the behavior, not just the behavioral metrics. So usually visualization becomes the final analytical interpretation layer. So that's what happens when you do the dashboards. So finally, the same analytical principle used in malware telemetry also applies in fraud detection, observability, platforms, IoT system, web analytics, and operational monitoring. Across all domains, the challenge remains the same: transforming event streams into analytical intelligence. Telemetry requires specialized modeling, behavioral analysis emerges through aggregation, and BI platform can analyze systems rather than simply reporting KPIs. So usually the same insight here applies in all domains. It applies in all domains. The most important thing to take away is that data shaping matters more than dashboard. So we usually believe that a dashboard is effective, but a dashboard is not effective. What is more effective is the data shaping, the underlying event data, the raw telemetry that was used to produce the dashboard, the layers that was used to produce the dashboard. And telemetry requires specialized analytical modeling. So for this to happen, we need specialists, we need people who understand what raw telemetry is all about. So we need people who understand what raw telemetry is all about. And Power BI and Fabric can become behavioral intelligence platform, not just reporting tools. So Power BI can also become behavioral intelligence platform, not just reporting tools. So before we close, I'd like to leave you all with one final thought. Which is predictions alone are not intelligence. So predictions alone are not intelligence. Insights usually emerge when telemetry is structured, when telemetry is modeled, when telemetry is analyzed, when telemetry is interpreted and communicated effectively. Ultimately, it's not just about dashboard, rather it's about understanding behavior through analytics. Thank you very much, everyone, and I'm happy to take your questions. Do you have any questions for me, please?
So I never worked with Fabric before, but I'm quite curious when you say the good model can scale up very good. Could you give me some examples?
Yeah. So good modeling, right? Modeling, analytical shaping. This is what matters when you want to create a dashboard. So understanding that dashboards, Fabric, Power and Power BI dashboards, they have more capabilities. They can be used for insights. They can be used for behavioral insights and more capabilities. So what makes a good dashboard is the analytical modeling, is the transformation, is the data shaping. This is what makes a very good dashboard. All right. Did I answer your question? Okay.
Okay.
Obviously, a lot of the things you've done there are taking the JSON and then processing that, and probably quite a traditional way of how you get the data out. Have you thought about the other ways of processing that? So you're using the data, I'd say, historically then to go look at the behaviours and things like that, and putting that on the dashboard to understand what's happening. What other ways have you looked at? Is that how you're interpreting the data from where you're getting it, or is there other ways you've thought about sort of doing that within Fabric?
Yeah, there are other metrics you can use. There's a metric called Spark. There are other models you can use within the analytical layer that's going to produce much more accurately or much more insightful dashboards.
Okay.
So it's not just a one thing. There are other ways you can transform the data, other methods you can use that can bring about a better dashboard. Right. Okay. Person.
Sorry, can you go back to the first page where you show us the full pipeline?
Yeah. You mean this one?
Yeah, that one. So I've got a really simple questions. So if I can do all the jobs, like 80% or 90% of the job in Power BI alone, like I can getting data from a CSV file and an Excel file. I can create next measure. I can do the data modeling. I can also create dashboard. I can do everything in Power BI. So is it necessary to what's the benefit?
Yeah. Okay, that's a very good question. Yeah, if you can do most of it, right, it's very beneficial to you because then you're going to be valuable to your company, right? You're going to be valuable to yourself as well, and it's a knowledge that you can use on your own. But the main essence of this session is to say that Fabric BI can do all this for you, right? So you don't have to do that on your own. It's like AI is put everything together for you to be able to okay.
So in your example, what you just described, beginning with raw data, my question is this modeling to be useful if you have like raw data set instead of, for example, you have everything pre-processed, clean. Let's say you have created a view in Snowflake, you configure it however you want, and then you load the data from Snowflake to Power BI for Fabric. Will there be any additional benefit for that data, or is Fabric particularly useful when you just describe raw data sets that will take a lot more effort for it to build those pipelines to understand the data?
So could you rephrase the question?
Yeah. So my question is, what you just described there in your presentation, is it more useful if the CSV JSON files are unstructured, and then for a human it would take a lot longer to understand the data, clean them, put them in a logical form, and then put them in Fabric? Because, for example, if you have that structured data in Snowflake, my understanding is that there's little benefit to put that into Fabric and then from Fabric to Power BI, instead of putting it directly to Power BI and not Fabric.
Yeah, that's what I'll say is there is more benefits in my own aspect. That there's more benefit when if you put the data directly into Fabric, for example, right? Fabric is going to like do the normalization for you and do everything you need to do, right? But if you want to do that on your own, it's usually going to take a lot of time because of the cardinality level. Imagine you're going through like series of event data, right? If you're going through series of event data, globally, you wouldn't want to go through that on your own. So it's gonna be easier if you can. It's gonna be easier for you if you can use the techniques or use the model to do that for you.
And my experience with Fabric is question. I would like to ask: is it easy to understand what Fabric does, or is it more of a black box that kind of figure things?
Yeah, it's easy to understand it. It's easy, but you need to put in the work to understand it too. Yeah, because it takes a lot of time to kind of get it. Right?
So I think what I'd say, if you've got structured data in Snowflake already, it probably wasn't structured before it went to Snowflake. If it's been processed in Snowflake, there's probably no need to process it again in Fabric. You could use Fabric instead of Snowflake, and they're basically two products that can do the same thing. It's whether or not potentially there's a benefit of having a unified platform so it's all in one place, versus kind of that more modular sort of kind of modern data stack approach where you go with best in breed. So there's not a right or a wrong answer to that, to be honest. I don't think you would build a pipeline like that if you've already done the hard work. But you could eliminate Snowflake and do it all in Fabric instead. And Fabric can work with both structured and unstructured data. But then Snowflake can as well, so.
Yeah, and I also think where Fabric also comes into place when you have a large team whereby they use different technologies. So you could have like data model in Snowflake already, and you want to have like one platform where you could bring that already model data into Fabric. So it's kind of like a unified platform where you could bring pieces together.
About skills, isn't it? I think, what you're going to do is, like John was saying, if you've already got it in Snowflake, that some of that would have been done already, so say 50% of that. Again, I'm trying to be careful what I say here, just from my history. Snowflake doesn't have a native good reporting solution, usually Tableau or something like that at the front end. So you'll probably, if you're doing this in Snowflake, you'll do Snowflake, and then the reporting would be Tableau, but it could be Power BI off the back of it. And you can do the same with Databricks, etc. So again, although this solution is all Fabric, again, it's similar across any of those, and they all work together, better together in some cases. But you know, again, it's about what skills you've got, what investments you've made on that. Again, Microsoft would love you to put it all inside Fabric.
Yeah.
Yeah.
And then you can get into the realms of do Snowflake mirroring now, can't you?
Yeah.
Snowflake mirroring is just the fact that you can do it in Snowflake and then just make it look like it's in Fabric, even though speaking it isn't.
Yeah. Iceberg, Delta, all the same.
So the answer is just yes.
Yes. It depends. Get consultancy.
Yeah.
How do you think the machine learning output will change the transformation layer within between the raw data and machine learning? Do you think if you kind of transformed it before feeding it into the machine learning model, how do you think the output would change, or would it?
Yeah, it would change. Yeah, it would change. So you try and say if you transform it before you get the machine learning output.
Yeah, just from the raw data kind of cleaned it, you did what you needed to, and then fed it into the machine learning.
Yeah, what I think it's going to start from that point.
Yeah.
Right. It's going you're cleaning it, right? But it's going to start as a raw data from the beginning.
Yeah.
You get what I'm trying to say? So it's going to start as raw data and it's still going to go through that pipeline again.
Okay. Yeah, two transformation layers.
Yeah.
Yeah.
Yeah. So, often this heuristic semantic model slow down the performance of the dashboard, causing latency issue or the performance issue. So, during the next Fabric is providing this.
Sorry, I can barely hear you. I can give you the mic if you want to. Sorry.
Yeah. So the semantic model often causes this latency issue, especially this huge model, which basically delays the performance of the dashboards and the response time gets slowed down. So is there any alternate solution which Fabric is providing? Can you use other things?
That's a good question. One of the challenges is that usually if you go through the slow computation, right? Slow computation, and it takes longer time when you do it traditional way. Because of the high-cardinality level, and it's going to take a bit longer time. If I'm getting your question, if I answer, just tell me. If I don't, I'm going to answer it again. But it's usually going to take a longer time, right? If you try to do it, I would say the traditional way, it's going to take a longer time, right? But if you're using, for example, if you're using the word telemetry, if you're using Microsoft Fabric, right, it's going to be faster because now you're imputing semi-structured data, you're imputing semi-structured data, you're inputting cardinality outputs, like you know what data you're using. For me, for cyber security, I know the what data I'm using. Raw data can be events data, it can be timestamps, it can be DLL behavior API calls, it can be callback, right? It can be callback, it can be communication, C2C, communication and control, right? So it can be so many things, right? So if I, for example, want to do all this on my own, it's going to take me a longer time. But if I decide I want to put all this information in Microsoft Fabric, right? It's going to, I already have a dashboard. For example, we call it maybe like SIEM software, where you go on the software and you, on the dashboard, you can easily see alerts, you can see security alerts on the dashboard, right? But as an analyst, if I want to sit down and do thousands of computers on my own, then it's going to take me a longer time to do that. And just using the software, right? Or just using the Microsoft Fabric BI, right? That answers your question.
unified solution which Microsoft is providing, is it gonna improve the performance of the dashboard? Because earlier we used to definitely import data from ours, so what the unified solution?
Yeah, it's going to be, the unified solution is going to, in essence, it's going to increase the performance of the dashboard. It is going to increase my own perspective too.
Is there any particular like type of modeling you use on your semantic model? Like what form of modeling do you use? Do you use a star model or a smooth
Doesn't matter,
or
like the star, snowflake, if the data is heavy, so eventually it's gonna have
because like how you also plan your
Because,
semantic modeling also helps performance as well. So like do you have any particular type of modeling you use in your business?
yeah, I mean, like, we use mostly star tables, so, but the issue is that the data is heavy. You can further divide into different models, or what we are used to do is, you can deploy, rather than having the semantic model in Power BI side, you can deploy the model into the analysis services, the analysis service in Power BI, report from there, and then once it's explained, just for
Do you sort of know like what capacity of Fabric?
so
Do you know the capacity of Fabric?
What licensing are you using? Pro, using Power BI?
So we are not using Fabric at the moment. I'm just asking that how the Fabric is managed.
Because I was going to
Just buy more capacity. Like,
Yeah.
just buy more
Yeah,
capacity.
like,
Just put your credit card down and you can find.
So you have a question there.
Thanks to the organizers of the program. I think to help us, to be nice if we could have like a session on what Fabric is all about, because it's a relatively new product from Microsoft. Most people don't actually, because from the questions that are being asked, most people don't seem to understand the usefulness of Fabric. So, to answer the question here, I would say it starts all the way from in the breakdown of the flow charts. You have to plan your data to reduce or to increase the performance of your dashboard. You have to, normalization works a lot, depending on the size of your data. You can break down your data and then use your star schema to join your data together. Then you also have to remove unnecessary columns that you don't use. Your DAX formula also matters a lot. I've realized that using filter in DAX slows down performance of my dashboard. So you rather use maybe switch, that will increase the performance. So those are some of the things, the best standard practices that you have to take note of to make your data, your dashboard perform better. In terms of Fabric, I'm not used to Fabric at the moment. It's sounding more like the usefulness of using a iPhone and also an Apple iPad. Having been in the same ecosystem where you could open something on your iPad and then just switch to your iPhone and continue using it. It's more like what Fabric is. You have the SQL Fabric, you have your data pipeline in the Fabric, the database, the transformation, and the visualization. So it just makes it easy for you to use. Unlike coming from Snowflake and then trying to bring it into Power BI, you have functionalities that you have in your Snowflake, that won't bring out the insights you are trying to do on your hardware. So it will just make it better doing all those things in Fabric. Of course, there are some other things you have to consider, the cost of Fabric at the moment is quite high. That's why most organizations rather use